Okay, class again. Good morning. We'll now try to interrelate the column beam or the beam column concept I just uh, shared to you earlier on frame analysis. Okay, so you will be using a lot of the beam column concepts when you are analyzing now frames. And frames can be analyzed two-dimensionally or three-dimensionally depending upon your capability, in terms of computer applications, because you cannot do it by hand. No, you have to do or need the help of a computer to really come up with a fairly accurate and fast analysis. So the content of frame analysis are actually more defined in the code in terms of the different types of frames. Okay? So ito yung mga normal, basic na makikita natin sa code. If you Okay, so we have frames wherein shear walls are uh, are actually placed. Okay, so by the way, this content here are made to specifically to emphasize, no, yung ating brace system, no, yung bracing system natin, no? So parang ito yung list of frames or frame types according to bracing. And when you say bracing, ang ating pinaka concern, our main concern here is against, okay, against lateral forces. The gravity forces uh, must of course be taken care of initially, but since lateral forces are the ones causing the frame or the building to overturn and collapse, then bracing system are more concerned about lateral, okay, lateral resistance. And the first type is for structures are shear walls. Okay, so these are made of these are RC, no, made of reinforced concrete to withstand the forces of earthquake. Brace structure, when you say brace structures, these are actually made up of normally steel members. Okay? Pag sinabing bracings, we are referring to, let's say I have here a building, and then the bracing system, as what my first video have shown you, I actually show the effect of a cross brace here. Okay, so this is a brace system composed of maybe a steel. You cannot do a wood bracing because wood is not that good, no, when it comes to resisting lateral forces. And concrete are not are can be used, but they are difficult to construct uh, in this form. Okay, so normally it's made up of steel. So this is now called a brace system or a brace structure. So for the frame tube, these are not very familiar yet, no, especially here in the Philippines. I'll show you an example of this later. Uh, Hybrid structure, of course, are simply the combination of each and every system that we offer here. Okay, and the I intentionally made the moment frames to be the last because this is the most common. No? So this is the most common. You can see from day to day, on a daily basis, you see moment frames, 1 story, 2 story, 3 story, up to about uh, 4 to 5 story. Okay, so pwede ka pang mag-moment frame without the need for all of this additional system, no? So ito yung pinakasikat, no? The most common, and this is the one. These are the ones that are um, very easy to conduct or undertake in terms of design and analysis. Okay, so we will be focusing more on this. And to give you an idea of how they look like, okay, so I just enumerated here a shear wall. So you see here the walls there at the sides, which actually resist most of the lateral forces, okay. And the shear wall, if you try to rotate it, okay, um, 90 degree, going to the right or left, it can form what you call a cantilever beam action, such as this. No? So you can see the resemblance of the beam or the cantilever beam behavior when you are analyzing a shear wall. Okay, so to point out now the use of what you call a diaphragm. Okay, so I'd like to magnify this and show you the floors. So this is now the floor, the 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 second, the third, the fourth, and the fifth floor there, or the roof deck floor, is very important or significant for the shear transfer to evolve, no? When earthquake comes. Without this floor serving as what you call diaphragms, okay, without this wall serving as diaphragms, then the integrity and the resistance of the shear wall can actually be uh, shall I say, reduced considerably kung hindi mo lalagyan ng diaphragms. And diaphragms must be rigid enough for shear transfer. Okay? So these loads here on the floor, you see this, the loads are transferred by shear, no? Okay? So for the MRF, or simply a moment frame, no? So in short, you can call this a moment frame, a moment resisting frame. There's a special moment resisting frame. There's an ordinary moment resisting frame. You can read them from code, no? But they mean the same thing. They are moment frames. They are made up of beam columns. Okay? So pag sinabi ko ng moment frame, diyan na papasok yung topic natin sa beam column. And this is just a very typical example of what the beam column, wherein the transfer of the loads are actually done through the horizontal beams and the vertical columns. Okay? So the beams or the girders are the part, the beams, the girders, the columns are the part of the moment frame. So, the slab acts also sa diaphragm, pero hindi masyadong critical. Unlike in the shear wall, pag wala kang floor, medyo mas delikado yung behavior ng shear mo kasi magkakaroon siya ng parang sa steel, lateral torsional buckling. Ito kasi concrete normally yung shear wall mo, no? Okay, for brace structure, meron tayong simple bracing. Okay, ang tandaan nyo lang sa brace, it means a two-force member lang siya, no? When you say two-force member, you are referring to simply a compression or a tension member. Okay, so it's either tension or compression. Kaya magandang steel dyan, no? Pag concrete naman, masyadong mabigat. Pag wood naman, masyadong brittle, no? And there are types of bracing according to the one popularizing it, no? So we have the cross brace, the K brace. Okay, yung shape niya makikita mo naman, no? The chevron, okay, chevron brace. Okay, sometimes called, you can also call this a knee brace, no? Parang knee type. And an eccentric brace system. The difference between the chevron brace and the eccentric brace is that your bracing does not form a purely triangular pattern. Ito kasi triangle lahat. Ito meron kang trapezoid dito, no? Pag nilagyan mo ito ng line dito, hindi na siya eccentric. Okay, hindi na siya eccentric. Concentric bracing na siya. Parang semi-chevron brace na siya, no? Okay, so if you remove this, it's now an eccentric. May eccentricity. So may konting additional movement yan, no? Okay, ito yung frame tube structure. Makikita nyo ang kapal ng column sa labas. Tsaka ang kapal ng beam sa labas, no? So the concept, the theory behind is that if you look at the floor plan, let's say this is the floor plan, yung gitna ay yung gilid, kaya tinawag na frame tube, is full of closely spaced columns. Yan. Puro columns yan. Tsaka beams, yung beams mo marami din. Okay? Pero sa loob, maaring konti na lang siya. Ganyan siya. Okay? So, parang ang nag-a-act ng system mo, yung tube lang. Parang ito lang yung tube. Gravity lang ito. Gravity columns lang ito. Yung mga columns mo dito sa gilid, which forms a tube. Now, resist all the lateral forces. Okay? So, something like this. Okay, spandrel beams, gaya ng sinabi ko sa beams kanina, yung beams sa gilid are called spandrel beams. Very stiff, very closely spaced din, no? Siguro may spandrel ka na sa ilalim, meron ka pa sa gitna, meron ka pa sa taas. Okay? Tapos window lang yung opening mo. Of course, normally wala naman door yan sa labas. So, sakaling meron man door yan, tatanggalin mo lang yung spandrel dun sa tatamaan ng door. Okay? This is an actual building in Chicago. Okay, ito yung mga differences ng moment frame versus brace frame, chevron brace. So, pag titignan mo itong moment frame natin, hirap na hirap yung columns pagdating sa cantilever projection niya, no? Samantalang ito, walang hirap yung column, ang nagdadala yung chevron bracing, no? Okay, so for moment frames, which sabi ko nga, ito yung pinaka-common, ito yung pinaka-madaling pag-aralan dahil marami na tayong softwares na yun. Ngayon, simple lang ang pagmomodel nito. So, it consists of steel, concrete, or masonry frames, no? O beam column siya. And there are two primary types, ordinary at special. Yung ordinary, pag wala ka sa high seismic region, pag special ka, nasa high seismic region ka. No? Like the Philippines, yung special, yung moment frame natin is special kasi 90% of the archipelago is actually within the zone of the Pacific Ring of Fire. Okay? Only in Palawan and Sulu, dun lang meron tayong zone 2, no? Okay, so special moment resisting are used for zones of higher seismicity. The steel moment resisting frames have been under intensive study and used in zones of low to moderate. Okay, pag steel kasi hindi natin pwedeng gamitin dahil nga mahina siya sa parang cantilever action, so might as well have bracings like shear walls, cross braces, etc. So the moment resisting frames may act either as a brace or unbraced frame depending on the additional moment caused by sway. Okay? Okay, so for the effect of swaying, there are actually three methods we have been using, no? So parang itong dalawa, ito yung direct analysis na pinag-aralan natin kanina, yung sa AISC, no? At yung moment magnification, ito yung moment amplification na method 3 natin na ginamit. Sa RC, halos parehas din, no? Wala namang pinag-iba dito. Kasi American code din naman yun. So the third method is the one that we will be, of course, discussing, as I told you a while ago. So note 2, since the effect of swaying is dependent on the end condition, a more accurate procedure to determine the K value. Okay, K is not the stiffness. No? Baka nagkakalituan tayo. Yung K dito is the effective length factor. Pag stiffness, ang symbol ko EI. No? Pag stiffness, ang symbol ko EI, flexural rigidity over L. Ayan, over L. Stiffness. Okay, so approximate values of K ang ginagamit natin dun sa ating mga problems. Usually, ito lang, no? 1. Kasi wala pa naman tayong mga pinag-aralan na ibang klaseng restraint. Pero pag ang restraint mo, may fix ka dito. Okay, kagaya nito, fix. Ang theoretical value mo, 0.5. Recommended is 0.65. Pag pinned fix siya, 0.7 tsaka 0.80. Pag itong dalawa, laktawan natin to. This is now a pinned 1-1. Ito yung mostly na ginagamit natin nung nagsosolve tayo ng compression problem. Pag free, tsaka fix, 2.10. Ito naman, itong dalawa are for unbraced, no? Itong natira doon, 1, 2, 3, 4 are for brace. Okay? So, itong unbraced, meron translation. Ito yung delta na pinag-uusapan natin kanina. No? Big delta. Ito, considered na unbraced din, pero pwede mong consider na brace pa rin kasi free naman siya. No? So, it can be tagged also on the unbraced if you want. Okay, so sama na natin siya dito. Para itong 1, 2, tsaka 3 doon are unbraced. Itong 1, 2, 3, brace siya. Okay, so this is 2, 2, and 2, 2. 2.10. But on frame analysis, this is not the one that we will be using. So this is only used for approximate analysis. Kung wala kang frame. For a more accurate and fair treatment of K values, we use the alignment chart or the nomograph. So ito yung ginagamit natin. So I will show you how to do this, and there are two types, no? Used for non-sway. Okay, iba na naman yung term na ginamit. Itong non-sway, ito yung brace, no? So iba-iba kasing code, kung minsan iba-iba yung gamit. Ito yung unbrace. Okay? So sa exam niyo baka magkalito kayo dyan. Iba lang yung term na ginamit. So for the brace or non-sway, the range of K is from 0.5 to 1, no? Tignan nyo, ito lang yung range niya. Hindi ka pwedeng bumaba, hindi ka pwedeng tumaas. But for unbraced frame, ang range mo naman is from 1 to infinity. Pero syempre, hindi ka nagagamit ng infinity dyan. Ang gamitin mo, siguro 1 to, ako hindi na ako nakakadating ng, ano ba to? 20 ba yun? Okay, so 1, 1.5, 2, 3. Hindi man ako nakakarating ng 3 eh. Dito lang ako. No? Pero hanggang dito pwede ka siguro hanggang yung before yung infinity, yung 20. Pero 20 is a very big factor to consider. Nakakatakot na yan. Okay, if you don't want to use graph, you can use the equations. The only problem with equations is that they are not American. This was not obtained from the American reference. I think this is a British standard. No? Hindi pa ako nakapag-search kung merong American counterpart itong equation na to. But you can use this, no? Wala namang harm, no? To mix it up. Okay, so the next is a problem. So we're going to solve this, but I will spare this time to the time to solve this on the next video. So I will end my lecture for this presentation now, and I'll address your concerns later. Thank you very much for listening.